Do you have that special someone who makes you feel all warm and fuzzy inside? Well, sometimes, so do moons. I'm Anna Barth, and this is the story of Io, tidal heating, and how celestial bodies keep each other warm. Io, one of Jupiter's moons, is the most volcanically active body in our solar system. With over 400 active volcanoes covering its surface, Io is just oozing with heat. But in the seemingly endless, cold loneliness of space, where is all that warmth coming from? For a lot of large planets with warm cores, we can trace their heat to two main sources. One, there's some heat still left over from when several smaller planets collided, forming the new planet. Two, there's radioactive materials within the planet which decay and release heat. The problem is, if we only look at those factors, Io should be stone cold. It's only the size of our moon, not big enough to retain heat from when it originally formed, and there's no way it has enough radioactivity to fuel the kind of incredible volcanism we see there. So what then is maintaining Io's molten core? To answer that question, we need to take a closer look at gravity. The attractive force of gravity between any two objects is stronger when they're closer and weaker when they're farther apart. For two celestial bodies, say the Earth and the Moon, this means that the side of the Earth facing the Moon actually feels a greater pull than the side facing away. The result is a stretching effect we call tidal force. If the Moon had its way, the Earth would be slightly oblong, like a football, and vice versa. The Earth wants the Moon to be football-shaped too. Here on Earth, the stretching on land is pretty minimal, although the water on Earth does get stretched, giving us the tides. Now let's look at Io again. Io is orbiting Jupiter, a massive planet, meaning that the force of gravity and the tidal forces are really strong. Also, Io's orbit around Jupiter is pretty oblong, so sometimes it's closer, sometimes it's farther away. When it's closer, gravity is stronger, meaning the tidal forces make Io more football-shaped. As Io approaches the point on its orbit where it's closest to Jupiter, the tidal forces increase and its surface swells as much as 330 feet. Then it recedes again as it goes back around the other side. So, as Io orbits Jupiter, getting closer at some points than others, it's being stretched and compressed over and over, generating friction, which in turn generates heat. When tidal forces create heat, it's called tidal heating, and this strange phenomenon, a natural consequence of gravity, is what maintains Io's molten core and fuels its astonishing volcanic activity. So if you ever feel like being close to someone just makes you melt inside, you're probably experiencing tidal heating.